range. And we're going to do a linear function as well as quadratic. Now, hopefully you guys remember some of the stuff you learned in grade 9. This is a linear function. We talked about the difference between linear by just looking at it. This one is to the power of 1. This is known as the y-intercept, or b, in y equals mx plus b. And this is known as the slope, 3. So I'm not going to go in too much depth about how to redraw that. I'm going to draw it for you. Hopefully you guys, this kind of comes back to you. If the y-intercept is -4 and the slope is 3 technically over 1, so rise is 3 and the run is 1, we're going to model this very quickly. -4 is y-intercept, and the rise is up 3 over 1, up 3 over 1, and it's going to go on. Did I go up 3 on that one? No, I didn't. There you go. Okay? So this is going to be modeled by something like that. There's our linear equation. So, our linear equation here. Let's talk about the domain and range. What would the domain of this be? Will it stop left and right? Will anything stop it? No. Nope. So what is the domain? No restrictions. Is anything going to stop it up and down? No. So what is the range? Y-E-R. Not always. That's example 1. Example 2. X equals 6. How do I draw that as a linear function? X equals 6. Anyone know? Yes.
Just a line through the X point of view.
Yes, exactly. So this is a linear line going directly straight up like that. Okay? So let's talk about the range first. Range of this one. Is anything going to stop this up and down? So what is the range? Good. What is the domain here?
Nothing.
Domain is just the value of 6. That's it. There's nothing else. There's only one number to that for a vertical line. Same idea with horizontal, just the y and x would be flipped. The y would just be a number, the domain would be every possible value. Finally, you've been given this. I don't know if you guys can quickly graph this, but I'm going to tell you that the y-coordinate, I'm now going to change these to values of tens, so I can fit this all on the same graph. Okay? This vertex is going to be at 100 on the y-axis, and it's eventually going to come down to here. Okay, so it's going to make this shape like that, and same thing the other way. Now, let's read this question. It says, a ball is thrown from a cliff. The flight is modeled by this function. So, on our x-axis is time, and our y-axis is height. Can I throw a ball, if this is time, this being 0, can I have thrown the ball before I threw the ball in negative values?
No.
No. So when does this start? When did I throw the ball from the cliff? At 0, and the height, you're right, is at 100 at that point. So, in other words, this function, this part of it over here, doesn't exist for what we're doing. Even though if we were to draw this out, this parabola would look like that. So you need to keep that in mind. I'm going to draw a line just to help us model that. So we start here, and then the height is measured in reference to the ground. Assuming I can't throw a ball through the floor or through the earth, where does the ball stop?
Like Y.
Out. Yeah, it's going to stop on our x-axis after how many seconds? 10 seconds. So, in other words, this function has only really existed in this area. Okay? So let's talk about the domain to start. The domain of the one we did in, oh shoot, let's do it in blue, okay? Domain. It is continuous, so it is XER, but did the ball exist before 0 in time? No, so the had to be 0 as our starting point for x. And when did it stop when it hit the ground? Value of 10. So there is a restriction on this parabola because it is a word problem. Okay, we know the ball can't go through the ground, and we know we couldn't have thrown it before we threw it. It wouldn't make any sense. The range of this. What was the highest this range went? Okay, it is continuous, so we start with YER. The highest it went was at 100. Okay, less than and equal to Y. What was the lowest it went? 0. So the lowest it went was 0. So there is a restriction on both of these because of the word problem. So if you get a word problem on your test and it asks you for the domain and range, try to make sense of the parabola. You'll know how to graph it. Try to make sense of it so you guys can set up our domain and range properly.